Alright, in section 5 we're going to look at the graphs of sines and cosine functions. So we'll be spending a few days on this topic, graphing some basic sine, cosine functions, and then looking at how the amplitude, and by changing the amplitude we change the graph, and by changing the period, and we'll look at those transformations and how do we sketch those graphs when those things have been affected. So first let's look at the basic sine curve. Okay, so we've got our axes set up here, and notice that the x-axis is now in terms of radians. Okay, we've got those angles, the pi over 2, pi, some of those more important angles, and if we really would break these down, this is really going to be pi over 6, pi over 3, and then pi over 2. So basically we're counting by 6. 1 6, 2 6, 3 6, and so forth. Okay? So that's how this x-axis has been divided up. And then we've got our y-axis simply counting by ones. Okay? So let's look at some of these basic things. Okay? If I look at the sine of 0, okay, the sine of 0 has what value? Well, the sine of 0 is 0. Okay? So we've got the point 0, 0. When I'm at 0 radians, I have a y value of 0. If I go up and I let my x be pi over 6, well, the sine of pi over 6 was 1/2. Sine of pi over 3. Okay. Well, that was square root of 3 over 2, so that's going to be just a little bit higher. Okay. And what about 1/2 pi, the sine of pi over 2? Remember, the sine of pi over 2 was 1. Okay. And let's kind of skip ahead here a little bit. The sine of pi. Well, the sine of pi was back at 0. Sine of 3 pi over 2, that dropped down to -1. And when I get back to 2 pi, I'm back at 0 again. Okay? So what's happening when we look at this sine curve is it looks something like this. Okay? And when we get back to 2 pi, remember that's basically we've completed one revolution and now we're starting over. So we would have these coterminals. So all of these values here that we've got in the first quadrant, remember once I start my second rotation, those values are just going to start repeating, and this graph starts to repeat itself. Okay? So we're looking at just the basic sine curve, and if we were to go back the other direction and we were to look at the negative values, well, if I talk about the sine of negative pi over 2, that's on the negative y-axis. That's going to be down at -1. Negative pi comes back to the x-axis. -3 pi over 2 is actually the positive y, and -2 pi. So if we go backwards through the negative angles, we see we've got that same shape. Okay? So we've actually started to kind of repeat. If I go from 0 to -2 pi, I've got the same graph in this range that I basically have over here from 0 to 2 pi. It's like we've taken the whole graph and we've just shifted it over. Okay? And we're going to look at what that means as we get a little bit further into this. Okay? But here in the blue and the red, we've got our basic sine curve, the red being the positive rotation, and the blue here showing a -1 rotation. Okay, what about the cosine? Well, let's do the same type of thing. Let's look at our axis angles, and what is the cosine of 0? Okay. Well, the cosine of 0 is +1. Okay. If I put in pi over 2. What's the cosine of pi over 2? Well, that was 0. Now it's going to be here. If I put in pi. I'm back on the x-axis, and I'm going to be at negative 1. Okay, so hopefully you're starting to see the pattern here that's developing. If I put in 3 pi over 2, that's on the negative y-axis. I'm on the y-axis, the cosine is an x, so that's a 0. And then when I come back around and get to 2 pi, I'm back on the positive x, so I'm back at positive 1. So the cosine graph for one revolution looks something like this. Okay. Doesn't look a whole lot different than the sine, other than it just kind of looks like the sine graph that's been shifted a little bit. If we were to go backwards a rotation, we'd see that we'd have negative pi over 2. Negative pi would be at negative 1. Negative 3/2 would be at 0. And negative 2 pi would put me back at positive 1. So it's still that same kind of rolling curve. Okay? And notice, where does it start to repeat itself? Well, I start at 0. Okay? If I start here at 0 and I follow it out, then when I get to 2 pi, I've gotten back to the same y value. And the graph will start to repeat itself. Okay, so let's change it up. Let's go 2 times the sine of x. Okay? And again, let's just look at those major angles that are on our axes just to get kind of a general shape. Okay? So y equals 2 sine of 0. Well, the sine of 0 is still 0 times 2. It still gives me 0. So I'm still starting at 0, 0. Okay? Let's jump to pi over 2. 2 times the sine of pi over 2. Well, the sine of pi over 2 is 1. So I end up with a y of 2. So when my x value is pi over 2, my y value ends up being positive 2. Let's go to, that's not cooperating very well, 2 sine pi. Well, the sine of pi, again, is 0 times 2 gives me 0 again. Okay. Sine of 3 pi over 2. Okay. The sine of 3 pi over 2 is negative 1. So at 3 pi over 2, I'm going to be at negative 2. Okay. And if we were to do this again for 2 pi, the sine of 2 pi is 0 times 2 is still 0. Okay. So now our graph looks like this. Okay. So what's different? Well, if you remember the initial graph was here. Okay. So what changed was basically how far up and how far down those maximums and minimums were. Okay, they were at 1, and now they're at 2. Okay, so we're going to be looking at what causes that change in those maxes and mins, okay, those high points and those low points in the graph, and how can we use those to just be able to look at the graph and kind of make a sketch based on what the original graph is and what our changes are. Okay. And that's where these values come in. Okay, when we look at the amplitude and the period of the sine and cosine. Okay, amplitude has to do with those maxes and mins. How high or how low does the graph go? And the period we talked about before, the period is when the values, the y values, start to repeat themselves. Okay, so when that graph starts to repeat the same pattern, that's where we're looking at the period. Okay, so we have this general form here with y equals d plus a sine of bx minus c, and then we've got a similar pattern down here for the cosine. Okay, and the a value, the number in front of the trig function, the coefficient, is what affects our amplitude. Okay, in the originals we had just sine of x, the a was 1, so our amplitude was the absolute value of 1. We went up 1 and we went down 1. But when we looked at the last one, where we had 2 sine of x, There our A value was 2. And remember, our maxes and mins came at positive 2 and negative 2. So that coefficient out there in front of the sine or in front of the cosine, whichever graph we're using, has to do with how high or how low that graph is going to go. Where are those maxes and mins? Okay? The period is the B value up here. It's the coefficient on our x, or on our angle. Okay? So the coefficient on that x value, if I take 2 pi and divide it by b, 2 pi divided by b, that tells me the period. That tells me how far that graph is going to go before it starts to repeat itself. So when we look at these original functions over here, in both cases, b was 1. So when I would take 2 pi divided by 1, I get 2 pi. And there is my period. And that's how far the graph went before it started to repeat itself. Okay? And I'm not going to worry too much about the stretching and shrinking. If b is a fraction, okay, remember that's going to stretch the graph out. It's going to make the period longer. Okay? And if b is greater than 1, then it's going to compress that. If I make b larger, then this 2 pi divided by b becomes a smaller value, and my period gets shorter. The graph will start to repeat itself faster, whereas when it is a fraction, then the graph will stretch out. It will take longer to start that repeating pattern. Okay? So we're going to look at a couple of more graphs and using these ideas. So here's a graph, y equals cosine of x over 2. Okay, so the first thing we want to look at is what is our A and what is our B. Remember, A has to do with the amplitude. It's the coefficient in front of the trig function, which in this case is 1. Okay. And B is the coefficient on x. Well, I've got x divided by 2. So what value is being multiplied by x? Well, if I'm dividing by 2, that really means I'm multiplying by 1/2. Okay? So in order to find my period, I take 2 pi divided by b. So 2 pi divided by 1/2 means my period is going to be 4 pi. Okay? Which means I'm going to get all the way out to 4 pi before my graph starts to repeat itself. Now, since it's a cosine function, at 0, remember the cosine function started at its maximum. It started at positive 1. Okay? So the beginning and we know the end are in the same spot. And the reason we came out to 4 pi is because that was our period. If the period is 4 pi, that's when I'm going to get back to the same point that I started with. So now we think about, okay, if we think about that basic cosine graph, okay, and I'll kind of draw that in here in a little dotted line. Remember the basic cosine graph looks something like this. It came down, went to 0, down to -1, back up to 0, and then back up to +1. Okay? So we had our maximums at the beginning and end. The minimum was right in the middle. Okay? And then when I split the difference on those two is where I cross the x-axis. So if I go back and I look now at my new function of cosine of x over 2, okay, you see at the end and at the beginning here, I'm at my maximums. My minimum would come right in the middle. Well, the middle of 0 and 4 would be at 2 pi. So that's where my minimum is. Okay. If we go back and look at the original, here was my minimum, here was my maximum, and halfway in between is where I crossed the x-axis, my 0. Well, halfway between 0 and 2 pi is at pi. So here I'm going to cross. Halfway between 2 and 4 is 3. So there's where I'm going to cross. So now my new graph looks something like this. Okay? It's been kind of stretched out, and not the best drawing there of the graph. It's a little bit difficult to do on these boards, but you kind of get the idea. We've taken that graph now and we've stretched it out rather than having these points here. So this point here that was at 2 pi in 1 has now been stretched all the way out here to 4 pi 1. Okay? Notice our maximum and minimum didn't change. I'm still only going between positive 1 and negative 1, and that's because my amplitude up here was still 1. I didn't change the amplitude of the graph. I didn't change where those highs and lows were going to happen. I just stretched out when they were going to happen. Okay, so let's look at number 5. Y equals 3 sine of x. So again, the first things we need to look at are the a value and the b value. The a is the coefficient on the trig function, which is 3. And remember, that has to do with our amplitude. The b is the coefficient on x, which in this case is 1. Okay? So if b is 1, I haven't changed my period any. My period is still going to go from 0 to 2 pi. Okay? And since it's a sine function, okay, if I put in 0 for x, the sine of 0 is 0 times 3, still gives me 0. But when I go to pi over 2, okay, instead of being at pi over 2, 1, like the original graph was, the sine of pi over 2 is 1, but now I'm going to multiply it by 3. So I'm way up here. So again, let me just quick kind of sketch in where the original graph was at. Remember the original graph kind of went up here, came down to -1, and back up to 0. Okay? So in orange there we have the original basic sine function, and now look where my amplitude is at. My amplitude has jumped all the way up to 3. Okay? The period hasn't changed, so I'm still going to have my zeros, my x-axis values are in the same place. So I'm going to go to here, and now at 3/2, instead of being at 1, that's going to drop down to -3, and it's going to come back up here. Okay? Okay. So there is one period. And if I wanted to graph another period, then when I get back out here, then my pattern, it just starts over again. So now it's going to go back up. When I get to 5/2, it's going to go back up to the amplitude. 3 is going to come back to 0. 7/2 down to -3. And 4, which is my second rotation, I end up back there. So the graph just keeps on going. Okay? And it would keep going in a positive and a negative direction. Okay? At negative pi over 2, I'd go down to -3. And then here I'd come back up to 0. And then I'd be up at +3. And then I'd be back at 0. So the graph is a continuous curve. And it would keep going. And notice that every 2 pi, my period, since b is 1, that means my period is still 2 pi from 0 to 2 pi, 4 pi, -2 pi. Every 2 pi, I've got the same looking graph. Okay? It just repeats itself every 2 pi radians. Every revolution, that graph starts to repeat itself. Okay. Alright, so take a minute, pause the video, and see if you can graph the sine of x over 2. And then pick it up and we'll finish going through it. Okay? So, A is 1, B is 1/2. So my period is 2 pi divided by 1/2, which is 4 pi. So it's a sine function. I haven't changed the amplitude, so I know I'm starting at 0. But now I'm going all the way out to 4 pi. Okay? So I've stretched everything out. So let's look at this. If I take and I put in pi over 2 for x, sine of pi over 2 divided by 2, okay, that really becomes the sine of pi over 4. And the sine over pi over 4 was square root of 2 over 2. Okay? If I go out and I put in pi for x, Then I had the sine of pi over 2, which was 1. So now I'm coming all the way out to pi to get my amplitude of 1 instead of pi over 2. I'm stretching that graph out. Okay? Or if we think about the original sine function, remember at the beginning, at the middle, okay, at the end, that's when it was at 0. Okay? So I'll throw in the original sine here for you again, just to refresh your memory. Remember, it comes up to 1, then it comes down to 0, then it's down to -1, and then it's back up to 0. So I got beginning, middle, end, and I'm on the x-axis. I'm at my zeros. The same thing is going to hold true for my new graph. It's a sine function. Okay? So when I'm graphing it, the beginning, the end, and the middle would be at 2 pi. Those are all going to be on the x-axis. Okay? And notice in the original function in green, a quarter of the way through at a half pi, okay, the middle of the first half is where my maximum was. The middle of the second half is where my minimum occurred. And the same thing here with the red, with the new graph. Halfway between the first half, right in the middle of the first half, is my maximum at +1. So, right in the middle of the second half, which is at 3 pi, I'm going to be at my minimum value of -1. And the reason I'm still at 1 and -1 goes back up here because my amplitude is still 1. So all we've really done once again is just kind of stretched out that sine curve. And if we wanted to graph one more period, then we could go backwards in a negative fashion. Okay? Where now at -pi, I'm going to be at -1. Okay? From 0 to -4, that's my period. So beginning, end, and middle. Okay? A quarter of the way, halfway from the first half, I'm at the minimum. Halfway at the second half, then I would be at the maximum. So the graph would continue back this way. And there I have graphed 2 periods. Okay? That's 2 periods of the graph. I've got 1 period going from here out to 4 pi, and then I've got another period going back this way, back to -4 pi. So I actually have 2 periods of that sine function. Good. All right, so tomorrow in class we'll look at day 12. We'll work on some more of these graphs, and then the following day we'll look at how do we look at those transformations. Remember, if we go back to where we had those equations, how does this minus bx minus c and the plus d out front, how do those things affect the graph? And it's going to look a lot like the transformations we did with polynomials back at the beginning. We're going to be shifting the graph left and right, up and down, and we'll look more about how we can do that and what are some of those shortcuts. Okay? So, we'll see you in class tomorrow, and we'll get on those graphs.